Alrighty, Tommy Reed here. I want to give you a little update. Got some goodies in finally. I did get some of my pipe fittings in. This was a tank. I ended up cutting this and burned it. I wanted to get all that crap off. So when I lightly sand it and prime it and paint it, it's going to look nice. This is the bottom part to the rotary union. I want to show you what we ended up doing. Right now I ended up just lining this up basically. This is my turbine. I got 4 turbines on here. And basically what that's going to do is, let me take this off real quick. Gives you a pretty good idea. I got 36 holes an inch apart. So we got 360 degrees, basically 36 holes. The rotary union comes in handy. I think this is a Valvor. Hey, for the money, I can't complain, so it works pretty good. And this is basically the setup. These are my rims. I'm going to have to rethread some of this, shorten it just a little. And basically, this is good. The turbine. Now, these are 1 inch. So actually, they're 3/4 inch. So they're going to have some really good kinetic energy when they actually spin. This is a special fittings that you can order online. This is a 6-hole. So perfect. And what I'll do is put it on the lathe, and that's this little cheap lathe I bought a couple of months ago, actually. $600. I cannot complain. Someone added a little bracket for it, but overall it's not perfect, but it does the job. So I'll end up threading this down and fitting my 1-inch shaft in there. And on the other side, I'll end up putting the thread for the 1-inch thing. So this once I get this on the lathe, it'll be perfectly straight, and this is my main shaft. So I'll stick this in here to a certain point, then weld it, and that gives me my thrust itself. And we have the elbows. This goes from 3/4 to 3/8, and that's where I actually drill my jets. So I'll drill it, looks like about either 1/16 of an inch would probably be the best bet on the thrust. And so all this is coming together. I'll be welding this to the bottom part, and then everything gets sandwiched together. I'll show you a good find I just got. Got this on Facebook. He said the engine is locked up, which it appears to be, but he wanted to just get rid of it. $20. Now, I'm actually, I could say I'm an expert at all this stuff because I worked on it. I'm very good at these engines and the generators, so I know all about this stuff. And my main objective is actually getting just the generator. Yeah, it does have to spin at 3,600 RPMs. I can change the capacitor in it and make it running a little bit lower RPMs, but to get to 60 hertz, you're going to have to run this at 3,600 RPMs. Usually this is a 5,200 watt. Technically, you can get away with about 7.5 horsepower, but they usually double the horsepower. So if it's a 5,000 watt unit, most likely it's going to be a 10 horsepower, and that's because of the surge. When you get a surge, a heavy surge, it's going to bog down that motor, and sometimes it stalls it. So they usually double the horsepower compared to the wattage that you're using. So this will work out really good. This is actually electric start, which is, I mean, just the parts alone is worth some money. I'll probably tear the engine apart and look at it. Sometimes you can back them off, but usually if they're seized, they're going to be pretty much locked up. And that is actually a common thing on these engines, is that they have an oil sensor, and sometimes these oil sensors, they fail. So when it gets low on oil, it doesn't shut off and just runs until they basically run dry. So it'd be interesting to tear that apart. I'll probably show a video on that. That'd be pretty interesting. Now, if the engine is shot, what I would do is actually, I would cut off the main shaft because it's a spline and leave it attached. And then from that, I would actually machine it down and put a block bearing on the front of it. So then I can actually have a pulley that actually drives the generator. Now, 3,600 RPMs, I did some math. Basically, I would need a certain amount of power to do that. And how you actually can calculate that, if you ever want to know how much torque you have, what you would do, you have to figure out how many how many horsepower do you need? So if you go by the horsepower or divide it by the 746 watts, this is the simple formula to actually work that. So you got to spin this at a certain RPM. So what you would do is take the horsepower, like say 10 horsepower, you actually multiply that by 5252, and that's going to give you the amount of torque, and then you actually divide that by the RPMs, and that's going to tell you the amount of torque you're going to actually need to actually run this. Now, I'm going to try to get away with about 7.5 because I can get away with a lot less because it is a constant. This is a 4-stroke, so that's why they recommend usually double the horsepower on this. So if you can see, this is actually 11 horsepower engine, so not a problem. This is all simple stuff for me. But the main thing is I'm going to need to run this up to at least 3,600 RPMs. So I did the calculations on this. What I can do is actually make it probably about 1.5 ratio. It means basically if it spins 1, the pulley's going to make it actually spin 1.5 times more. So around roughly, I can keep this around 1,800 RPMs, maybe a little bit less. And I would have to actually double that. But this is going to go at 500 PSI, I calculated. It's going to be about 2,500 RPMs. Now, that is no load. So I have to make sure I get the amount of thrust that I need. But with a counter rotation, which is a very unique design, the counter rotation adds more torque to it. And I may have a Sprag gear that reacts to counter reaction with a nice planetary gear up top. That way it gives me both kinetic energy coming out from both sides, not only the thrust, the reaction thrust, but also the Pelton wheel, basically the cups that are actually collecting the water and causing it to rotate, almost like a water wheel. So I could do that. So other than that, everything is coming together. These were not too bad in price. The shipping was actually pretty high, but it's okay. To get these kind of fittings are very difficult sometimes. So it gives you a pretty good idea of what is actually going on. So I probably I got to get bolts. And these bolts I'm going to have to bolt all this, but I got a lot of welding to do too. So what I end up doing on this is basically bolting it to the rotary table. And when every 10 degrees, that gives me my gap right there from the circumference. So it gives you, that way I can, up top, I end up having a O-ring around it. And then that way I can seal the top, but down below it's going to be welded. That way there's no leaks, and also it strengthens it. And then at the end, once I get the bottom actually cut, I'm going to end up cutting the bottom plate with enough diameter right here where this will actually open this up. And then I'll be able to sit that and make sure it's all level and then weld that around here. This is basically where it's going to hold most of that liquid. And I did a flow test, basically. At 3 gallons, it fills it up to about here. So I want to at least have 4 gallons of fluid in here at all times. And it adds to the weight and the stability. The generator is going to be a little tricky. I may have to, I don't know if I want to put that on top. I could, but I definitely need the RPM. So I would have to have some kind of gear ratio or some type of a planetary gear to get the 2-to-1 ratio. To get this up to 3,600 RPMs. If I get it 2-to-1, I only have to run this 1,800 RPMs, which is not a problem, by the way. The calculations are very clear that if it's 1,000 PSI, this thing will actually get up to almost 5,000 RPMs, which I don't want it to get that high, don't need to. Well, number one, I won't have the thrust. So once you cut that back to 2,500, say a max is 28 pounds of thrust, foot-pounds. Well, the max, or even 20 foot-pounds with 1,000 PSI with the 4, basically a 1/16 of an inch orifice, that should give me at least 10 pounds of thrust, which at 2,500 RPM should be more than enough to actually be able to do some serious work. And that's pretty much the update. Even if I get 5,000 watts or even 3,000, at least I can start doing the math and figuring this all out. Tommy Reed, talk to you later.